Blah! And I'm here, looking at the sun in 193 angstroms. We see coronal holes facing the Earth. We see massive global current induction spikes caused by nothing more than magnetism. We're going to talk pretty in depth about the Gong 2 data. First, let's look at the setting sunspot here. That's sunspot 2756 setting there in the northwest. Here's the equatorial region. We're looking at about 10.5 hours of data here on January 11th, 2020. How's your vision? Is it clear? And let's look at 304 angstroms. We see a giant plasma filament up in the northeast. Here's the southern region. And there's the northern region again. 10.5 hours of data there. We are back to 0 sunspots, folks. And here's a close-up of the that filament up there. Quite a bit larger than the entire planet. Please leave a comment if you're viewing from a different one. And here's the GOES X-ray flux. We saw a couple little tiny B-class flares here yesterday. Nothing really noteworthy there in terms of X-ray flaring. 10.7 centimeter radio flux. A commonly used proxy for sunspot number in terms of solar cycles is at 73 solar flux units. KP index is at 2. And we're going to get to that global induction spike in a minute. First, let's look at cosmic rays. And there is the cosmic ray situation at Apatity. And here's Barentsburg. And you're looking at 24 hours plus the last 30 days at these two neutron monitors. Next, we'll look at Athens, Greece. As cosmic rays become a more and more important subject of study, as atmospheric physics get actually understood, we'll keep covering these every couple of days on the channel here on the daily space weather videos. So here's the Athens neutron monitor looking pretty flat over the past 30 days there. Next, let's look at Mexico City. And there's the situation at Mexico City. Now, this is one that you can access the old data on, folks, so I encourage you to do so if you've got concerns about what was happening with cosmic rays on a given day. This one's got great controls, although the data may look jumbled when you request it. Moscow hasn't been sending data since the end of 2019. Here's Oulu, Finland, and one Antarctican monitor. There's Oulu. And you can see tiny downtick over the past 30 days at Oulu. And there's DOMC Antarctica. Sending some spotty data there. DOMB Antarctica not sending data at all. If you want to monitor cosmic rays, click the links below the video. We keep the network of cosmic ray stations in the links in the description, so you can monitor them yourself and don't take our word for it. Now, we saw a global spike happen here, right at around this time right here. So around 8:20 UT. And basically what we're seeing there is just a complete lack of protons. I mean, look at the proton levels. 0.05 protons per cubic centimeter. That is an incredibly diffuse solar wind there, folks. And we see a shift in the phi angle right after that. So that was like that was the precursor to the coronal hole magnetic connection, and perhaps that's yet another signal that can cause us to forecast when coronal hole magnetic connections take place. If so, that's a breakthrough in terms of solar forecasting. Anyway, the current phi angle is up at 300, and we've got a coronal hole facing the Earth. It's fairly far north, and it would be no surprise to see a magnetic connection to that throughout the day today. And since then, we have seen the BZ head up into positive territory. And we're going to be crossing the current sheet too, so lots of stuff going on at the same time, folks. Again, very diffuse coronal wind. Current solar wind speed is less than 1 proton per cubic centimeter there. 0.79 is the latest reading I see. And we even see a ramping down of the solar wind speed here down to 421. It was about 500 yesterday. So very, very weak solar wind. Full-on solar minimum conditions. And the electron flux has risen a little bit as forecasted here. There's the relativistic electrons. And that's about 5-day-old data there. And here's the GOES electron flux, which popped up just as we forecasted. No surprises there, but there's the data. And not expecting to see this reach the alert threshold anytime soon. Here's the ionosphere map. And it's actually looking a little bit more normal than it has. As we've been monitoring significant South Pacific anomalies here for about 2 months. And those anomalies I'm talking about are down in this area here, southeast of Hawaii, off the west coast of South America. They seem to have actually subsided quite a bit in the past week. And the ionosphere is actually looking pretty normal right now. There's the latest image coming in at 10:45 UT. GOES magnetometers are going to continue to be all spiky and sawtoothed over the next 24 hours. So watch for that to happen as another heliospheric current sheet polarity boundary gets crossed and the Earth ends up back in the South Pole-oriented portion. In fact, we could already be in the South Pole-oriented portion. That could be this extreme change right here. We'll look at the Gong 2 in a minute. From the top view ecliptic plane field plot, first we're going to look at the line of sight ecliptic plane field plot because I want to explain what the top view ecliptic plane field plot is showing you. So, when we're looking at the line of sight ecliptic plane field plot here, the B field is drawn in here in blue. And this gets affected greatly by sunspots more so than anything else. And when we say that the polarity is changing, that's the polarity for our location in the solar system. If you are only less than a degree off of the solar equator, it could be a completely different environment than what you experience on Earth. And this is why we have this blue line drawn in. This is showing us where the actual the net field is located. And this totally has to do with the BTBZ. And without getting super in depth into it in the daily space weather video, perhaps we will cover it more in the cosmology section. The point is, when we're looking at the data from stereo A, which is out here somewhere, stereo B, which is out here somewhere, and from Earth, we're only looking at a tiny sliver of the current sheet, basically just the portion in the middle. Every time plasma traverses the current sheet, it obscures portions of it. Now, here's the top view ecliptic plane field plot. I don't know why it says synoptic. It's top view ecliptic plane field plot. Let's just load it so you see what we're saying here. And you can look at old data on here, and I encourage you to do so, especially if you don't understand the way this relates to solar activity. Now, here's the latest images from the top view ecliptic plane field plot. Keep in mind, this is only sampling a tiny portion in the center of the current sheet around the solar equator. That's the part on which you live, and the Earth never strays, as far as we know, and as far as we hope, very far from the solar equator. That's the celestial equator. Anyway, this data is 1 hour and 55 minutes old, and you can see the way the fields are suddenly shifting around, not only on the far side of the sun, but also on the near side of the sun, and that is because of magnetic activity on the surface of the sun. Things like sunspots affect this, and things like coronal holes don't really affect this. Now, let's explain this a little further here. So, Stereo A is located about here where my pointer is. See my pointer there? That's where stereo A is. And so this view is essentially upside down. You can see all these planets. Stereo B is out here, by the way. You can see all these planets on the opposite side of the sun. We have a viewer who claims that the solar activity somehow is governed by where these planets are located. In other words, the reason that these fields are flipping around out here on the opposite side of the sun is because of the planets being there. And I can't say more how incorrect that is. However, change my mind. If you can prove me wrong, feel free. Let's go back to the regular mobile version that we usually look at. And here's where things are located currently in the solar system. And there's where they'll be in 1 week as Venus swings around to take a pass and Mercury creeps up on it. Let's look at the Gong 2 data from September 11th through September 15th, 2012. Now, to our regular viewers, that's probably going to look a little bit different than normal, right? And this is what the Gong 2 data looks like in terms of the top view ecliptic plane field plot when there's high levels of sunspot activity. So this is what an active sun looks like, folks. Now, I'm not suggesting that this is the same type of planetary alignment that's happening right now, where all the planets are on the opposite side of the solar system and Jupiter and Saturn are practically in conjunction. It's not the same scenario as that, but I'm just showing you how to access the data. Just head here, put in what dates you want. I'm not sure how long this data is available for. Just you have to mess with it. This is where the planets were located at that time. And again, I'm not suggesting that it's a similar planetary alignment or anything, but let's just get on to more data here as we've got to get the video produced. And by the way, thanks for citing the ideas and attempting to do some science. Now, here's this global current spike that we saw, and it was purely magnetic in nature as the geomagnetic shield was down when this thing hit. So this thing came in at 820 UT, and you can see it's actually low velocity, and this is because there's so little plasma there. There's nothing obscuring the fields, folks. Again, I say this practically every day with certain people in science discussions. Plasma is not the magnetic fields. The plasma orients to the fields. If you get the two confused, your chicken and egg concept of the way the universe works is going to be completely skewed, and you will be completely confused. Now, that looks like high density, and that's a magnetic spike in the density. So you can see the way the magnetosphere is all puffed up, as low density is shown here in white. This is all caused by this incredibly diffuse solar wind. And let's just watch that density spike come in. That is a magnetically induced density spike, as no solar wind data whatsoever indicated that. But a phi angle change came right after it, indicating it's probably what we would call a tidal effect. And it's the sun's rotating tidal effect magnetic fields that we're talking about. Here's 4 hours of data from terms of magnetohydrodynamic pressure. And here's this extreme spike, and you're going to see the magnetosphere reverberate. Almost no plasma in the bow shock there for a moment. And then everything kind of replenishes itself as the system attempts to reach equilibrium. What's going on there? Well, the Earth's giving up electrons. And let's just run this back here for a second. You can see right here, very weak magnetosphere, practically no plasma in the bow shock. And then all of a sudden, bang, massive pressure without a massive density spike. So that's a magnetic effect, folks. That's just the way it works. And magnetohydrodynamics is a new emerging branch of science as well. I encourage you to study it, as it's what really affects the way things operate in cosmology. Here's that spike once again. That is a magnetic spike inducing massive pressure, and that's magnetohydrodynamic pressure. If you want to know how this data is gathered, folks, check out the space weather modeling framework. Just click down here on details. Click the space weather modeling framework and you can read all about it. It's not just magnetometers, folks. It's also measuring the solar wind and the electron flux and countless other things. Let's look at the view from the ground magnetic perturbations, and we see a massive spike here on the ground also coming in around 820. So let me just pause it here at the peak. You can see it looks like a couple of spirals on the ends of the planet, and that's because there is a Birkeland current going into and indeed out of both ends of the planet. And we're not going to get into the to the generation of the Earth's magnetic field right now, but we'll just let this play through. Let me bring that back one more time here before we look at it from the global view. And we see the main spike here is east of Greenland, which is right on the net north geomagnetic pole. As we see two poles up there, the main spike did come in on the net. In terms of the south, we see the spike coming in surprisingly far to the west, as we would expect it more like in the southern Indian Ocean, headed toward off the coast of Australia. That's not where we really see it. We see it more toward Madagascar. So that is another interesting feature here. And this is the most real-time data you're going to see in terms of polar excursions. And this is why we look at 4 hours of it every day. Let's look at the globe view. And there's the view from the globe. I'll bring that back again and rock that through so you can see where that spike ends up. And it looks awfully far to the west as far as the southern hemisphere. The northern hemisphere looks practically perfectly centered over the net north pole. In other words, where your compass would point is practically right where that main change in the magnetic field happened. We are going to show you data about power grid ground induction, which was surprisingly uninteresting from the U.S. perspective, as there was not a big induction spike in the power grid, at least not according to the data that I see. And you can see that's calmed down, basically just caused by a combination of very low solar wind and magnetism. So here's the geoelectric field, and it's starting out right as you would expect to see that spike, right around 820, but you don't see it. And we do have this linked in the description as well. We'll let that play through for you, just to see that there was practically no induction induced in the U.S. power grid, at least. Everything looking quite steady despite that magnetic spike. By the way, I don't know if you're aware, parts of the U.S. power grid are already hardened. I've checked. Have you signed up for the forum yet, folks? It's smashomash.com/forum. And thanks to our latest members there, thanks for signing up, those who have. The latest entry just came in a few hours ago, maybe an hour ago. The most massive object known in the Milky Way galaxy is Sagittarius A star. The most massive radio source known, the supermassive black hole at the center of the galaxy, is a source of much academic and theoretical debate. More on this in the galactic current sheet later. Let's look at earthquakes, as I haven't even delved into it yet. There's too much stuff to cover, and I see red as Puerto Rico gets hit with more quakes, aftershock after aftershock. People are afraid to go back into their homes, folks. It's an unfortunate situation. At least one person was killed down there in Puerto Rico, and our hearts go out to them, hoping that everything gets... Keep them in your prayers, folks, because we're hoping that they get everything rebuilt. I believe much of the power has already been turned back on. So let's look at the deep quakes here at least. We see a 5.0 at Vanuatu. And otherwise, not a lot going on there. Again, there's a 5.2 in Puerto Rico. Tons of aftershocks there. Looks like the largest of the past 24 may have been this 5.4 at off of Raoul Island there, north of New Zealand. Small deep quake at Alaska. We've seen a small uptick there. Here's an uptick in South American deep quakes, as we've been seeing for months. A 4.1 at Chile at 118 kilometers. East Timor sees a deep quake at 151 kilometers and a 4.5 magnitude. Very deep quake strikes the Fiji Islands, 518 kilometers, and we regularly see that area as the deepest quakes in the world. And let's look at the volcano list, which includes Kluchevskoy back on the list, producing a 20,000-foot ash plume there. Please don't pole vault Kluchevskoy. Mount Aso, also flight level 8,000. Kuchinorabu Jima in the Ryukyu Islands erupted, produced a 9,000-foot ash plume. That's somewhere by Japan. And lastly, Sabancaya exploding, producing a 24,000-foot ash plume. Please do not fly over that in your home-built kit helicopter. We've got some lightning strike in the U.S. as this massive convergence line, 1,500-mile line of storms here. Check it out. Mississippi. What do we got? Oxford. Hey, Oxford. There's thunder rolling in. Check out lightningmaps.org if you hear thunder. Let's talk about global warming. Global warming and climate change update, folks. Were you aware that windy.com has a wonderful mobile app? Well, check it out. They've even got snow depth on there, folks. Snow depth. Just click on layers, click on more layers, and there you go, snow depth. Let's check out the current state of affairs. Greenland's still not melting. We covered it all summer where it had 9 feet of snow from coast to coast practically. Anyway, there's the snow in the northern hemisphere. And we're not even going to show you pressure maps today as we don't want the video to be too long. We're producing at least one more video today, possibly 2. Here's this year's snow mass. And this doesn't even include mountains, folks. And as you can see, it's a standard deviation above the norm, which is 1982 through 2012. And I don't know if you're aware, but snow and cold go together, not snow and warm, and carbon dioxide has nothing to do with the climate. Here's your snow forecast for the U.S., and this is going through, I thought I was going through to Monday here. There's through Monday, January 13th at 12 noon Universal Time. It's wintertime. There's snow. It's very warm where I am. Here are the jet streams of the eastern world. Let's flip this around to the western world and keep this thing moving before we become old and gray. Not that there's anything wrong with that. And you can see that southerly flow, which is injecting massively warm air into where I'm located. We're expecting a high of over 60 degrees today and possibly a record breaker tomorrow in the Lehigh Valley, the record being 65 degrees. The forecast, last I checked, was for 64. Extreme meridional jet stream flow is the rule of the last couple of years. And let's check out the U.S. Doppler radar map here, courtesy Weather Underground. Please leave a comment if you think Weather Underground is named by a terrorist organization. I really have no idea. But check out that straight line of storms there. And let's take a quick look at the Arkansas-Missouri border here. See what's going on there a little closer. And there's the current state of affairs there. Some pretty violent looking storms there. And we'll just look at the water vapor map real quick. Thanks to everybody who tuned into the premiere, by the way. We like the live premiere events as I'm not only smAsho, but I'm also a client. So there's a water vapor map. Let's just zoom in on that same location. So all y'all looking at the Doppler radar, not knowing what'll happen next, we'll get a better idea. As the water vapor map shows you water that's invisible. It shows you the water that's not condensed onto the clouds, as well as water that is condensed onto clouds. And we'll give you an idea of the way the stuff is going to flow. And you can see that drier, more massive air is going to be pushing this through, and it's going to be taking its time headed east, thanks to that warm air, meridional jet stream flow. Keep in mind, folks, warm, moist air is less massive than dry, cold air, and that's largely the way the atmosphere works. Thanks, patrons. If you haven't considered becoming a patron, please do so, as we've got a lot of things to do in 2020, and most of it is even secret from you patrons. So the more encouragement we get, the more we'll be able to accomplish our goals, such as making your contributions tax deductible by creating a nonprofit organization. We've already got the .org. If you haven't checked it out yet, check out smAsho.org. Please consider pressing like and subscribe on YouTube. There's going to be another cosmology segment coming today. We did a real basic one yesterday, so perhaps check that out. Transients, crabs, and the most, oh my. And thanks again, Smash Team, for viewing and watching us not stagnate in any way, but continue to grow all of the different portions of our mission in various ways. Stay tuned for some bonus features. Here's a close-up of the colorized magnetogram. There's former sunspot 2755. There's a plage that was not a sunspot. And over here is the setting of sunspot 2756, which is actually looking pretty organized from this angle, but that angle is so oblique that really hard to tell what you're looking at from that angle. And here's the view in 171 angstroms. Let's hit refresh on that to show you the current state of affairs with all the magnetic looping. Looks like there's some filament activity kicking off over there also around former sunspot 2756. And let's animate one more movie here. How about the 131 angstroms view? And it's a 48-hour video, folks. You should see most of the life cycle of 2756 as it sets over the limb. We are out. Again, look for at least one more video, probably two today, as there's a lot of stuff to cover yet. Thanks everybody who's assisting us in going full-time on this, as we have taken yet another step in the process of ensuring that the content continues to increase in size and quality, and scope, indeed, as we'll cover more and more subjects as time goes on. So remember, everybody, to stare at the sun, not to drink, and if you do drink, don't drive. Really, don't drive. I could be out there. I don't want to see you. And since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.